This is concept development for Module 6, Lesson 15. This is template 1 on page 242 that we're working with. Now, looking at letter A, look at this segment on letter A. How do you know if the lines in problem A are perpendicular? How do you know that these are perpendicular? What could you say about them? Well, let's take some notes. So if you have a pen or something like that or a pencil, take some notes. So the lines intersect at the corner of the grid squares, right? So they must be perpendicular. So we signify that by going like this. That's the symbol. So I can put the corner of my paper at the vertex, or I could put my set square at the corner of the vertex, and I can see that it's 90 degrees, right? So this set square right here. So I'm proving by using my set square that this is 90 degrees. What else could we say about letter A? Well, let's add some more notes. The lines that intersect create 90-degree angles. And we know 90-degree angles are always perpendicular. Perpendicular. Oh, something really important. The sum of the two angles, I'll just keep adding some information up and around here. The sum of two 90-degree angles equal 180 degrees. We also know the sum of two 180-degree angles is equal to 360 degrees. Or you could say 4 times 90 equals 360 degrees. You could say 2 times 45 equals 90 degrees. So the sum of the four angles of two intersecting perpendicular lines is 360 degrees. So back here, 90 and 90 is 180. You're adding another 40, another 90, and another 90. So 4 times 90 is 360 degrees. So these are all the same right angles. And so they are perpendicular. So now let's look at B, C, and D. You can use your protractor if you have one. Is that a 90-degree angle? Yes, it is. Will this intersect? That's going to create a 90-degree angle. Could I use my set square here? Yep, that's a 90-degree angle. And then if I turn it and use my set square this way, is that a 90-degree? Well, is that a 90-degree angle? No, because a 90-degree angle would fall along the outside of this ledge, right? So this angle is actually an 80-degree angle. So this one is no. This one would be yes, yes, yes. All right. Moving on. Really quick, take out, if you've got it, take out your little triangle from lesson 14. And what if I have two. I have both of them. Remember how we cut and then we cut it? So I'm going to take this one and I'm going to fold that top angle. What do you notice when we fold that top angle? Well, angle T is now hiding angle R, right? But it still is a 90-degree angle. What if we folded it in? It wouldn't be perfect, would it? Maybe that's just because of the way I cut mine. Maybe mine's not cut very well. So S and T, angle S and angle T completely cover R with no overlap. Angle S and angle T must add up to 90 degrees. So this is what I want to show you next. So using my protractor. Now, if you remember that a triangle, all the angles inside the triangle. So we know that R is equal to 90 degrees. It is a right triangle. So I wonder what the angles for T and S have to be. Do you remember the rule for the angles in a triangle? Angles in a triangle equal how many degrees altogether? 180 degrees. So if we know that angle R is equal to 90, I wonder what T and S actually are, what angles they are. So let's play around with this for a second. I'm going to use my grid right here. So I'm going to make sure my R is a 90-degree angle. So I'm going to use my protractor to make sure, yes, it is R goes straight up to 90 degrees. Now let's find the angle for angle. I'm going to do it this way. Okay, I'm going to turn it. And we're going to try to figure out what this angle actually equals. Okay, so I'm trying to figure out what angle S equals. So what I'm going to do is I'm going to put S at the corner and I'm going to follow the line. So let's say it's 20 degrees. So if we have one right angle R is equal to 90 degrees, and we have angle S is equal to 20 degrees. I wonder what angle T is going to be. So what do you think? What do you predict? Remember, the angles have to add up to 180 degrees. So let's take a look here. So I'm going to flip this. So I'm trying to figure out angle T now. I'm going to put my set square here, and I'm going to follow the line to T. Oh, it's 70 degrees is angle T. So 70 plus 20 is 90. 90 plus 90 is what? 180 degrees. So yes, these three angles follow the rules. So these angles, as long as this is 90 degrees, you have to figure out, and I just showed you using my protractor how I was able to twist and turn, not twist necessarily, but turn my triangle to figure out what the other angles measured. 70 degrees. Do you see that? How it points straight up to 70 degrees. And then we had to figure out what S equaled, right? So we had to stick this S over here at 90 degrees and equaled 20 degrees. See how that angle measured 20 degrees. All right, so let's go back to what's our objective today. Our objective is to construct perpendicular line segments on a rectangular grid. So this is just bonus information here. So let's put our straight edge. So what I want to do is I want to look at problems 1, 2, 3, and 4. And I want to practice constructing perpendicular line segments, and I want to add up the acute angles and a straight edge. All right, so let's get started. Now, if you have your little triangle, great. If you don't, that's fine too. But you're looking here at number 1. Can you imagine the triangle here? So do we have, yes, it's 90 degrees. Therefore, this line is perpendicular at this spot here. So this is a perpendicular line. Now, how would I create a perpendicular line with this line segment? We could use our triangle. How would we know that that's perfectly perpendicular? Could we use our set square and create another perpendicular line through this line segment here? So if this is 90, what is this angle here? This is a 40-degree angle. And what is this angle here? Well, it shows 40 and about 35, so that can't be, because it has to add up to 90. It has to add up to 90 degrees. So how do we find out? We can measure, like I just did. What is another strategy? We know it has to add up to 180. So let's see if we can figure this out. Now, we're going to use the top number here. So we're measuring 60 and 40. This would be a 60-degree angle. This one looks bigger though. Let's try it this way. Whoops. And 40. So a 40-degree angle and a 60 oh no, it'd have to be a 30-degree angle and a 60-degree angle in order to add up to 90 degrees. All right, let's try problem 2. Let's try to create a triangle in here. All right, so what angle does this create? That's 90 degrees. We can use our set square to make sure we have a nice straight line, to make sure it's 90 degrees. Now, we could use our tool here, our protractor, to measure the other two angles and see what we get on those. So let's turn and use our protractor. So this is a 20-degree angle. And let's measure this one. Oh, it's 70 degrees. 70-degree angle. All right. Now, let's do number 3. And keep in mind, going back to all the information that we know about perpendicular lines, because that's our big idea for today. We know that is a perpendicular line. We're using our set square. Let's measure this line here. That's going to give me about 60, I'm going to say. And that's going to give me, oh, that one's giving me 62. So maybe I'm not doing something right. So let's take a look again at our angle. Oh, it's 30. That's a 30-degree angle. I was looking at the protractor wrong. And then this is a 60-degree angle. So let me fix this here. 30 degrees. So notice how that doesn't make sense. That's not going to work. So let me go back and figure out where I made a mistake. Then this, we know this is perpendicular because it goes along the straight edge. And what do we know about perpendicular lines? The lines intersect at the corner of the grid squares. The lines that intersect create 90-degree angles. 90-degree angles are always perpendicular. The sum of two 90-degree angles equals 180 degrees. 4 times 90 degrees is 360, and the sum of two 180 angles is 360. All right, back down to number 4. So here is a 90-degree angle. Now let's see about lining this up. So I get about 70 on this angle. So let's see if I get 20 on this angle. Ooh, I did. So I got 20 degrees here. 70 degrees here. I love when things work out. So let me show you again using my protractor. Here's a 20-degree angle. Wait. And then here is the 70-degree angle. All right. So our big idea for today is making sure you know what are the rules for a perpendicular line, how to construct a perpendicular line. Then also one other important thing is to know, let's use our RST. Let's use our RST angle. So this is 2 units down, 1, 2, 2 units down, 1, 2, 3, 4, 5 units across. So let's start over here. Let's trace our, and then 2 units up, 1, 2, 3, 4, 5, 5 units across. You can use your straight edge here with your triangle to connect those. Or just use your straight edge. Now, we know that this is R, this is S, and this is T. Now, and we worked with this yesterday, remember, in the last few days, increasing, and how do we make perpendicular lines? By moving it across, right? Then these two lines become perpendicular. Now, what if I switch it and I go this way? So it'd be 1, 2, 3, 4, 5. Up 2. Now, what did we say was the measurement for angle S? What was the measurement for angle S? Should we measure it? Okay, measure S. That was a 70 degrees and a what? Wait, I need to put it this way. 20. So our 20-degree angle and our 70-degree angle with our 90-degree angle. Now, if this is 20 degrees and I just flipped this triangle and this is angle S, what will this angle equal? You're right, it would also be 20 degrees. Now, what did we say about a straight line? How many degrees is a straight line? A straight line is 180 degrees, right? So if I have 20 here and 20 here, what would this angle equal? So what's 180 minus 20 minus 20? Well, that would be, so this would be equal, this angle would be equal to 140 degrees. That's how you figure that out. That would be the same over here. What if I drew the same triangle in this direction and I ended up with a 70-degree angle? Oh, this would be, I think I have these flipped. I think this is 20 degrees and this is 70 degrees. So what if it was 70 and 70? You can do the same thing for these other triangles, you could try to figure out if you drew another triangle exactly like this one going in this direction. And if this was 30 degrees, so 30, 30, so 180 minus 30 and 30 would be 60, right? Would leave you with this angle would equal 120 degrees. Do you see how we're figuring that out? All right. So that's going to do it for our concept development on perpendicular lines. So our next, you're going to go ahead, you don't need to use those or cut those out. Here on problem set, you're going to circle the pairs of segments that are perpendicular. You can use your tools, your set square, or your other tools in order to figure this out and prove it. Circle the pairs of segments that are perpendicular. In the space below, use your right triangle, your set square. You could use your other little triangles, templates to draw at least three different sets of perpendicular lines. Then, problem 3, draw a segment perpendicular. So you could use your set square to each given segment, showing your thinking, or by sketching triangles as needed. All right. Then draw 2 different lines perpendicular to line E. So what do you know about perpendicular lines? How do they have to intersect? Right? All right, you're drawing those. Then you have your exit ticket, and then simply your homework. All right, I think this is going to go well. Check back for the problem set debrief.